This is podcast 2.1, and we're going to talk about the history of the atom and atomic theory. We have had lots of different models of the atom throughout the years. You can see this is Democritus and Dalton, what they thought the atom looked like, all the way to what we have now as our picture of what we think an atom looks like. If we look back at Democritus, which was in 400 BC, he's the first one who proposed the idea of an atom. So he said that all matter is made up of atoms and that atoms are indestructible, and he said that you couldn't cut them down any further. That lasted until Aristotle. Aristotle said that he was wrong, and everyone believed Aristotle, and it stayed that way for 2,000 years. That's when John Dalton came along in the early 1800s. He reintroduced the idea of an atom, and he went along with the same lines of Democritus in saying that it's indivisible, you can't break it down any farther. It's a solid sphere that looks like this. And then along with his new model of the atom, he came up with Dalton's atomic theory. He's often referred to as the father of the modern atomic theory. So there are these 5 postulates, 5 ideas that he has. Matter is composed of atoms. All atoms of the same element are identical, and he goes on and on. Most of these are right. There's a couple of these that are wrong. All atoms of the same element are identical. That is not correct because we now know about isotopes. And then the other one with atoms are indivisible and indestructible, that is not true because we know about subatomic particles. So there were a couple of things that he was incorrect on, but for the most part he had the right idea. So after Dalton comes J.J. Thompson. J.J. Thompson discovered the electron, and he has the chocolate chip cookie dough model, which is also called the plum pudding model. What he envisioned the atom to look like is the dough would be all this positive charge, and then within that dough we would have these spots of negative charges, which he knew were the electrons. So he still thought it was a sphere, but it was just positive charge and then the negative charge kind of in there. And then Ernest Rutherford came along, and he discovered during the gold foil experiment that the nucleus is actually in the middle, and it's really small and dense, with the electrons orbiting then around the nucleus. With his gold foil experiment, what he did was he had a radioactive sample in here. It emitted alpha particles, and alpha particles are just protons. So he emitted protons, and what he expected to see was that if the atoms were solid spheres like what they thought, then all of these alpha particles that they were shooting should have bounced back. They shouldn't have seen anything going through. What they did find is that most of the alpha particles went straight through the gold foil. So what that told him is that atoms are mostly empty space because these alpha particles were able to travel straight through the gold foil. And when they did encounter something, they kind of got deflected. So that tells them that the nucleus must have a positive charge because the alpha particles have a positive charge. And we know if you try and put 2 of the same charge or 2 positive sides of a magnet together, they're going to repel each other. So he got a lot of information from running that experiment. We have Niels Bohr. Niels Bohr came after Rutherford. He built on the idea of electrons in orbits. So we have the electrons traveling around like planets around the sun to the nucleus. And then we have our current model, which deals with an electron cloud. We now know that electrons do not travel in set paths like Niels Bohr thought. They have areas where they're most likely to be found, and it's not a nice, neat orbit like this. And if we look at this picture, what you see are these blue dots. That tells you where the electrons are most likely going to be. And you can see it's not a nice, neat ring. But what we see is when we add more energy levels, you would get a bunch of dots starting then again out here. So you end up seeing sort of like what you would call energy levels. They're just not neat and defined like they were here with the kind of the orbits. Okay, and that's the end of the podcast. You don't need to know too much more about the history of the atom or atomic theory. You just really need to know the highlights and the important scientists that we highlighted here and their models.